Welcome dear student. We have yesterday in the chapter number 5 inside the atom we have seen the Bohr's stable orbit atomic model and the atomic structure. It means atomic structure we have covered nucleus, proton, neutron, extranuclear parts and electrons. Now we will move towards the chapter. Okay students, use your brain power. Before starting the chapter we will see some of the questions. So first is, how many types of subatomic particles are found in atoms? So student, you can see a picture in which you can see subatomic particles. Okay, these are neutron, protons, and these particles are, so there are mainly four types of particles are present: protons, neutrons, electrons and extranuclear part, which you can also see in the picture. Extranuclear part is a part between the nucleus and the orbit, empty space between the nucleus and the orbits. Next is, which subatomic particles are electrically charged? Protons and electrons are the electrically charged particles, out of which protons are positively charged particles and electrons are negatively charged particles. Which subatomic particles are present in the nucleus? So students, you can see in the picture, inside the nucleus neutrons and protons are present. Protons are positively charged and neutrons are neutral. Where are electrons revolving around the nucleus placed? So electrons revolves in a specific orbit around the nucleus. You can see a blue colored orbit in which on which the orange electrons are revolving around the nucleus. Students, the mass of an electron being very negligible, therefore the mass of an atom is mainly due to the protons and neutrons in its nucleus. Students, yesterday also in our previous session we have seen that the mass of an electron is 1800 times less than that of the hydrogen atom. Okay, that's why the mass of an electron is being negligible and the mass of an atom is due to protons and neutrons. The total number of protons and neutrons in an atom is the atomic mass number of that element. The mass number is denoted by the symbol A. That means number of protons and neutrons, it is called as a mass number and it is denoted by symbol A. Here you can see number of neutrons plus number of protons is equals to mass number A. The convention to denote atomic symbol, atomic number and mass number are together is shown as follows. Students, you can see here X is chemical symbol for an element, and which is on the upper side of the X, it is mass number. Mass number means number of proton plus neutrons or the nucleons, and Z denoted to the atomic number, that is number of protons only in a nucleus. Okay, Z means only protons and mass number A means protons plus neutrons. For example, the conventional symbol carbon C612 means that the atomic number, that is the proton number of carbon, is 6 and the mass number of carbon is 12. You can see in the picture as well. From this, it is also learned that the nucleus of carbon contain 12 minus 6, that is 6 neutrons. Students, nucleus of carbon contain 6 neutrons and atomic number of carbon is 6, mass number is 12. Distribution of electrons. As per Bohr's atomic model, electrons revolve in a stable shells or orbit, and these shells or orbit have a definite energy. Okay, that means energy of a particular shell is definite. Okay, is fixed, something fixed. The shell nearest to the nucleus is called the first shell. Okay, shell nearest to the nucleus, first shell. The next shell of the first shell is called as the second shell. A symbol small n is used for the ordinal number of a shell. That means first, second, third. Okay. The shells are referred to by the symbol KLMN corresponding to the ordinal numbers n is equals to 1, 2, 3, first, second, third, fourth. Now students, K is the first shell, that is means nearest to the nucleus, L second shell, M third shell, and N is the fourth shell. The maximum number of electron a shell can contain is obtained by the formula 2n square. So by this formula we can calculate the number of electron present in one specific shell. As the magnitude of n increases, the energy of an electron in that shell increases. Students, here one table is given to us in which we have to calculate, a symbol is given, okay, and number of ordinal number are given. So by the formula we have to calculate the number of electron, okay, but I have shown already the formula and number of electrons. So students, for the first K shell, the formula is 2 raised to 1 square, that is 2. So in the first K shell, 2 electrons, maximum 2 number of electrons will be there. In the second L shape shell or orbit, the maximum number of electron will be 8, and third M shell, maximum number of electron will be 18, and fourth N shell, maximum number of electrons are the 32. So these are the electron capacity of the shell. Electronic configuration of an elements. The shell-wise distribution of the electron in an atom of an element is called the electronic configuration. So student, basically what is the electronic configuration? It is the arrangement of an electron in a particular shell or orbit around a nucleus. This is nothing but an electronic configuration. So each electron has a definite energy as per the shell in which it is present. Energy of an electron in the first shell is the lowest, and energy of the electron in the subsequent shell goes on increasing with the ordinal number of the shell. So student, we have seen that we have seen in our previous session that when the electron will jump from inner orbit to outer orbit, its energy will increases, okay, but when it jump from outer to inner orbit, its energy will be decreases. So likewise, in first shell the energy will be lowest, very low, but as the number of a shell increases, its energy will also increases with the ordinal number of the shell. So energy of an electron in the subsequent shell goes on increasing with the ordinal number of the shell. The electronic configuration of an element is such that the energy of all the electrons together is the maximum possible. Electrons get a place. Now students, here you can see a picture on two pictures, and in the right hand picture you can see a positively charged nucleus present in the center, and around which and around the nucleus 4 orbits are there. First orbit is K, second L, third M, and fourth N. So these are the shells around the nucleus. Now students, here you can see an example of a chlorine atom. Yes, you can see here an example of a chlorine atom. So in chlorine, okay, atomic number of chlorine is 17. So electronic configuration will be 287. That means in K shell it will hold only 2 electrons. In L shell 8 electrons will be there, and last M shell 7 electrons will be there. The electronic configuration in the form and the electronic configuration in the numerical form contains numbers separated by commas. Here the numbers indicate the electron number in the shell with increasing order of energy. For example, the electronic configuration of a sodium. So students, atomic number of a sodium is 11. Now it means that the total 11 electrons in sodium are distributed as 2 in the shell K, 8 in the shell L, and 1 in the last shell, that is M. You can see in the diagram also. Valency and electronic configuration. students, let's answer some question. What are the symbols for the shells which accommodate the electrons in the various atoms? So K, L, M, N to the ordinal atom. Ordinal number is first, second, third, fourth are used for the shells. What is the symbol and ordinal number of the innermost shell? The innermost shell of an atom is K shell with ordinal number 1. Write symbol of electronic distribution in shell of fluorine atom. Electronic distribution of fluorine, that is F atom, is equals to 2, 7. 2, 7, as the atomic number of fluorine is 9. So in first shell it will have 2 electrons, in next L shell it will have 7 electrons. Which is the outermost shell of a fluorine atom? Students, L is the outermost shell of the fluorine atom, in which it contains 7 electrons. Which is the outermost shell of sodium atom? M is the outermost shell of the sodium atom, in which it contains only 1 electron. Which is the outermost shell of hydrogen atom? So students, K is the outermost shell of hydrogen atom, as the atomic number of hydrogen is 1, so it will have only 1 electron in its outermost K shell. Now here we have the skeletal of electronic configuration. Students, here you can see some of the atoms like a hydrogen atom, in which 1 electron, outermost shell it is 1 electron. Helium, first shell or outermost shell 2 electrons. Okay, lithium 3 electrons, 2 in first, 1 in last. Carbon atom 6. Okay, 2, 4. Fluorine 4 and 7. Neon 2, and last shell it has 8 electrons. Likewise, sodium, silicon, chlorine and argon. You can see the distribution of electron in these atoms. Now let's see what are the valence electrons and valency. Students, valence electrons is number of electrons in the outermost shell, whereas valency is the number of electrons required for full outermost energy level. So students, what are the valence electrons? These are the number of electrons in the last shell. You can see in the picture also. Okay, number of electron in this atom, the number of electron in last shell is 1. So 1 is a valence electron. Okay, and the last shell is called as a, or the outermost shell is called as a valence shell. Now what is a valency? So students, valency of an element is related to how many electrons are present in the outermost shell. So in this example you can see that 1 electron present in the outermost shell, that means valency of this atom will be 1. Now let's see the helium concept of valency and valence electron. So student, the concept regarding valency of an element, chemical bonds in compounds get clarified from the electronic configuration. Atoms forms chemical bonds by using electron of its outermost shell. So valency of an atom is determined by the configuration of its outermost shell. Therefore, the outermost shell is called as a valence shell, and also the electrons in the outermost shell are called as valence electron. It can be seen that the valency of an atom is related to the number of valence electron in that atom. Let us first look at the element helium and neon. So here we have to take example of helium and neon. Atoms of both these gaseous elements do not combine with any other atom. Why? These elements are chemically inert. It means that their valency is 0. So in the element which have the valency 0, that they are called as the chemically inert elements. Now students, helium atom contains 2 electrons which are accommodated in the first shell. You can see in the K shell, helium atom contains 2 electrons. Helium has only one K shell, right students, that contains 2 electrons, and the same is also the outermost shell. The electron capacity of K shell is 2. This indicates that the outermost shell of helium is completely filled, and it is said that helium has an electron doublet. Now student, what is electron doublet? That means the outermost shell containing 2 electrons, That's why helium is called as a electron duplet, and the electron is that maximum capacity of the K shell is 2 only. That's why it is stable. The electronic configuration of the inert gas neon contain two shell. That is, you can see in the picture, two shell, K shell and sorry students, K shell and L shell. The electron capacity of L shell is 8 and the capacity of K is 2. Valence shell of neon is completely filled. That means outer L shell of the electron is completely filled. Why? Because it contains 8 electrons. It is said that neon has an electron octet. Now helium is electron duplet, and why? Because 2 electrons in its valence shell, and neon is electron octet. Why? Because 8 electrons in its outermost shell. Argon is an inert gas. Argon is an inert gas having electron in the shells K, L, M. You can see here first shell 2, L shell 8, and M shell also it contains 8. Okay, and this atomic number of argon is 18. The electron capacity of the M shell is 18. However, in argon there are only 8 electrons in the valence shell M. It means that there are 8 electrons in the valence shell of inert gas. That's why argon is also called as an electron octet. Why? Because 8 electrons are present in its last shell. From this, it is understood that the valency is 0. That means they cannot combine with any other element to form a new compound or molecule. So when the electron octet is or duplet is complete, the electronic configuration of elements other than inert gases show that they do not have electron octet or their electron octet are incomplete. Regarding hydrogen, it can be said that it is electron duplet is incomplete. Now why it is incomplete? Because in the first of all, the atomic number of hydrogen is 1. Okay, and the capacity of the K shell is 2, but here it is in only 1 electron is present. Okay, that's why it is not an electron duplet. Atom of all the elements except inert gases have tendency to, that means inert gases, they don't combine with any other element to form a new compound or molecule. So atom of all the elements except inert gases have tendency to combine with other atoms, meaning that they have a non-zero valency. You have seen from the formulae of the molecules formed by combination with hydrogen. That, for example, H2HCl. That valency of hydrogen is 1. The electronic configuration of hydrogen shows that there is 1 electron less than the complete duplet state. This number 1 matches with the valency of hydrogen, which is also 1. Moreover, it is learned that electronic configuration of sodium is 2, 8, 1, and the atomic number of sodium is 11, and the valence shell of the sodium contains only 1 electron. So electron in the valence shell and the valency of a sodium is also 1. Okay, that means valence shell valence electron is 1 and the valency is also 1. So what is the valency? The number of electron present in the last shell. As seen from the molecular formula NaCl, NaH, etc., it means that there is some relation between the valency of an element and the number of electron in its valence shell. Thank you, students. The next part will be covered in our next session.